Now let's look at some problems that involve integration by parts along with substitution. So in this example, we're integrating x to the 15th times the sine of x to the 8th. So what we're going to do is first do a u substitution, and we're going to let u equal x to the 8th. Then du will equal 8x to the 7th dx. So now let's look at making the substitution. So here we will have sine of u, and then what we have left is x to the 15th dx. But if we look over here, we see that du only involves x to the 7th dx. So what we're going to do is think of this x to the 15th as x to the 8th times x to the 7th. Now we have x to the 7th dx, which we can replace with 1/8 du, and then the x to the 8th is exactly u. So our integral now becomes 1/8 times u sine of u. And now we're ready to use integration by parts. So let's make the table here, and the column here we'll have for things we're taking the derivative of and things we're taking the integral of. So since u is an algebraic function and the sine of u is a trigonometric function, we'll put u here in the derivative column and sine of u in the integral column. Now the derivative of u with respect to u is just 1. And if we integrate sine of u, we have minus cosine of u. And now if we take the derivative one more time here in this column, this will be 0. And the integral of minus cosine of u will be minus sine of u. So now we're ready to apply our little formula. So this is going to be 1/8 out front, and this integral now becomes the product of u and negative cosine u. So minus u cosine of u, and then minus, and we alternate these signs here, minus the product of these two, so that would be a minus sine of u, plus our constant of integration. And then finally, we're going to substitute back to the original variable. So we're going to replace u with x to the 8th. So we'll have minus x to the 8th cosine of x to the 8th plus sine of x to the 8th here, and then our constant of integration. Now let's look at an example that involves substitution and integration by parts with a natural log function. So we're integrating x times the natural log of 5x plus 7. So let's do the u substitution, letting u equal 5x plus 7. Then du will equal 5 dx. So now if we look over here, our integral, we have the natural log of u, and what's remaining is x dx. Well, dx can be replaced with 1/5 du. So let's do that over here. And now we have an x remaining. Over here we look and we see that we can express x in terms of u by solving for x, and we'll have that x equals u minus 7 divided by 5, or 1/5 times u minus 7. So now, making that replacement, we'll replace the x with 1/5 times u minus 7. And now let's just clean this up a little bit. Let's pull that factor 1/5 out front. So we'll have a 1/25 times the integral of u minus 7 ln of u. Now we're ready to do integration by parts. So let's make our table here. In this column we'll have the functions we're taking the derivative of. In this column we'll have the functions that we're integrating. And because we have a natural log function and an algebraic function, we'll put the natural log function over here, and we'll put the algebraic function u minus 7 over here. The derivative of ln of u is 1 over u. And if we integrate u minus 7, we get 1/2 u squared minus 7u. And now, since this is not going to 0 in the left column, our integral here becomes 1/25 times, and here we're going to take the product, the plus sign out front, of these two entries. So ln of u times 1/2 u squared minus 7u. Now, alternating signs minus, and now we're going to take the integral of the product of these two entries. So the product of these two entries will be 1 over u times 1/2 u squared minus 7u, like that. And now this here is something that we can integrate, but let's just simplify it first. So this is going to equal 1/25 times the natural log of u times 1/2 u squared minus 7u minus the integral of, well, when we have 1/2 u squared times 1 over u, we get u over 2, and we have minus 7u over u, we just get minus 7. So now this is something that we can integrate. So now I've cleaned off the area above this expression so that we have a little more space here. And now let's go ahead and solve the integral. So this whole thing here becomes 1/25, and we are done with this part of it. So we'll leave it as ln of u 1/2 u squared minus 7u minus, and this is this minus sign here. Now, how do we integrate u over 2? Well, u over 2 becomes 1/4 u squared, and then minus 7 becomes minus 7u, and then we have our constant of integration. And now we only have one last thing to do, and that would be to substitute back to the original variable. And if you recall, we had u equal to 5x plus 7, so everywhere we see a u, we're going to replace it by 5x plus 7. So we'll have natural log of 5x plus 7 times 1/2 of 5x plus 7 squared minus 7 times 5x plus 7 minus 1/4 times 5x plus 7 squared plus 7 times 5x plus 7, and then plus our constant of integration. And that would be our final result.